Hi all, today's topic is disk management. So, operating system is responsible for several aspects of managing the computer hard disk. So, under this, how operating system handles disk management, we are going to see these three subtopics: disk initialization, how operating system initialize the computer hard disk at the very first time, and how booting process is happening from the disk, and if something goes wrong in the computer disk, how operating system handles to recover the data from the disk. Okay, so disk formatting. So before storing any data, we need to partition the disk. So, and in each partition we will be having the n number of tracks, and in each tracks we will be having the sectors, where in sectors the actual data gets stored, and the disk controller is responsible for accessing the data in and out from the disk and the computer system. So in sector, each sector not only holds the data but also some other informations like header information. So in header information it will get to know in which partition and in which track and in which sector number the particular data gets stored, and also it has ECC, that's nothing but error correction code. It means while storing data into this sector, it will do some computation, and that computed result gets stored in the sector. When the same data is read by the system, it will recompute the it will recompute and verify the stored data with the recomputed result, and if both the thing gets matched, it assures that the data stored in the sector is not corrupted. Okay, if there is any if there is any mismatch between the stored value and the current recomputed value, it will say that the stored value gets corrupted. So in this way, operating system handles how the stored data is right, or some or the data gets corrupted. Okay, usually in a sector we will be storing data in the size of 512 bytes, 1024 bytes likewise. Okay. To use the disk to hold information, or to hold the files, the operating system does two things. One is partition, the other is logical formatting. So partition, as I said, the disk from the manufacturing side, when we buy a computer, we will be getting the hard disk as a single, as a single volume. Okay, so huge, suppose if it is of 128 bytes, something like that, we will be having that as an 128 byte. We need to partition it to manage it efficiently. For that, operating system partitions the computer disk into one or more groups of cylinders, and each cylinder will be treating as an logical disk. And so far those disks will hold those disks don't have any file system. So only using only when there is a file system in the disk, we could easily manage the data in a file format. Otherwise, if there is no file system, how the data gets stored is something like we could not track the data from where it starts, where it ends. So where our file gets started and where it ends, that we cannot track it. So that one will be saying as a raw partition. So by having the raw partition, it's of no use. It's very difficult to get the data from the disk. So that the operating system goes for logical formatting. So it means making the data as a file system. Okay. And apart from in file system, so apart from storing the data in terms of a file, it also has the information about the free and allocated space in a particular partition. Okay, so here operating system handles the files in terms of clusters, whereas in the disk, the same input and output operations will be considered as in terms of blocks. Okay, and the next is about boot block. So I think you will be familiar with how computer system gets started. So when we switch on the computer system or when we reboot it, the first thing it does is nothing but a program called as bootstrap program gets executed, where the bootstrap program is stored in a firmware called read-only memory. um, the bootstrap program is responsible for loading the kernel of our operating system from the secondary storage device to the main memory. Okay, and then our operating system gets loaded. Okay, if any change, since the technology is evolving day by day, if there is a change, if there is a change, if there is a need to change a bootstrap code, then it's highly difficult to change the code because it's a firmware. Bootstrap code is stored in the ROM hardware chips, so we could not change it easily. We need to change the ROM chip itself to make any change in the bootstrap code. So to avoid this difficulty, there is to avoid the difficulty, instead of storing the entire bootstrap code in the ROM, only a tiny part of the bootstrap code gets loaded in the ROM, and the full bootstrap code is stored in the hard disk, and that part we are saying as a boot block. Okay, and initially when we powered on our computer system, only the tiny part of the bootstrap code gets executed, and that tiny part will load the full bootstrap code from the secondary device, and that bootstrap code is then responsible for identifying the boot partition. So boot partition is nothing but the location in the hard disk where our operating system is loaded. So that boot partition is otherwise called as boot disk or system disk. So here is an example how booting process happens in Windows operating system 2000. Okay, this is the secondary memory, where secondary memory is divided into 4 partitions, and the very first sector in the secondary memory is nothing but the code for the complete code of bootstrap. Okay, so that sector is specially named as MBR, master boot record. Okay, that little tiny bootstrap program identifies this location, where in this location the complete bootstrap code is stored, and apart from that it knows the knowledge of in which partition our operating system is loaded. Okay, so bootstrap program will then load our operating system. So this is the concept behind the booting process. And next is bad block. As I said, bad block is nothing but since hard disk is a moving parts, when time passes, some sectors may turn into a bad blocks, which means that that sector might be harmed, and we cannot use it in the later part, or while manufacturing itself, some sectors will turn to be a bad block in which we cannot store a valid information. And what happens when we store the information in this sector, and when time passes the sector gets corrupted? How operating system handles that corrupted sector? So it handles by means of something called as sector sparing or forwarding. So what it means? So it's nothing but disk controller will have some spare sectors, and if any sector goes harm, so that will be replaced by the spare sectors, and of course the data in that sector will be lost, and there is and the data loss might be avoided by using the soft error. It means using the soft error concept, there is the possibility of recovering the data from the bad sector, and sometimes we could not recover the data from the sector which gets harmed highly, so that is said to be hard error. We cannot use that sector in the future. So only way to use that sector is by replacing using the manual intervention. Okay, so that's it about the disk management. And next topic is all about swap space management. I think we will be knowing swapping concept earlier topic itself. So swap is nothing but moving, exchanging the data. It means moving a process from main memory to disk and disk to main memory. Why the concept swapping comes in? So because when we execute a process, that should be completely in the main memory. But what happens if the process size is bigger than the main memory? So we cannot, the main memory cannot afford that process. So there comes the concept called as virtual memory. So what virtual memory says is, so we could load only the part of the program in the main memory, and we'll be telling the operating system that entire program is in main memory, and it gets started, but remaining part of the program will be stored in the secondary memory. So since it gets stored in the secondary memory, the performance get degraded. So why performance gets degraded? Because actually secondary memory is slower than the main memory. And the concept behind the swap space is nothing but to give better performance for the virtual memory system. Okay, so swap space is a space that will be either in the file system or in the hard disk. Okay, so swap space is nothing but a substitute for the physical memory, because when our process goes beyond the size of the physical memory, there comes the virtual memory concept. So how virtual memory holds our program means by means of a space called as swap space, either in the file system or in the hard disk. Okay, so it is used as a virtual memory which contains process complete memory image. So image in this sense, don't think of JPEG or PNG. So this process image is it's nothing but an executable file that requires while executing that process. Okay, swap space. Swap space is a space that is in the file system or in the hard disk. So okay, that has some amount of space. We need to always overestimate the space of the swap space when compared to our process size. Okay, we should not underestimate. When we underestimate the swap space size, then our program might not run. It will be aborted in between or may crash entirely. So it is always safer to overestimate the swap space either in the file system or in the hard disk. Though the overestimation wastes some disk space, it won't harm our program. Okay, so as I said in the previous slide, swap space can be reside either in the normal file system or in the disk partition, so in the secondary disk. So when we have a space in the file system, that is very simple to implement, but it is inefficient. So inefficient in the sense, navigating the directory structure and subdirectories to get the pages from the swap space it takes some time. Okay, so that's what we are saying, that file system, though it is simple, it is inefficient because navigation takes some time. And again, in file system there will be external fragmentation. So I think you will be aware of external fragmentation and internal fragmentation, which we have discussed in our earlier topic. Okay, so to overcome this disadvantage, or to improve swap space management in file system, we can store that search location in the cache memory. So even then also, traversing that location takes time. Okay, so that is a little inefficient under normal file system when we implement the swap space. Okay, so now consider swap space in the disk. Okay, so in the disk there will be no file system. Okay, so in a disk, if there is no file system, as I said earlier, we could not track where our file starts and where it ends. Everything will be considered as a chunk of data. Okay, so that we are saying as a raw partition if there is no file system in that particular partition. Every partition should have some file system, so that storing the data and retrieving the data from the disk is quite easier. Okay, so so in this partition, when we maintain the swap space, so it maintains, instead of the file system, it has its own storage manager that handles storing and retrieving the data. Okay, so here instead of file system, so when we maintain a swap space in disk, there is a separate storage manager which handles the data, how to store the data, retrieve the data in a very efficient manner by using algorithms, optimization algorithm to increase the speed of retrieving the data, storing the data. Okay, and again it causes internal fragmentation, but this internal fragmentation is short-lived. It means when we again rebuild the system, this swap space will be gone off, and again when after rebooting the system, new fixed amount of space will be allocated. Okay, so Linux operating system uses both file system and disk swap space also. Okay, and that we'll be seeing an example of swap space management for Solaris operating system and Linux. Okay, so in Solaris 1, text segment pages are brought into file system and thrown away if selected for pageout. It means text segment pages means might be a program code. Okay, so that is quite easier to move into file system, and if that needs to be pageout, means that pageout in this sense that needs to be removed so that the other page can be placed in the main memory system. So it is quite easier. Text segment page in page out will be handling that code will handling text segment page in and page out is quite easier when compared to other non-text pages. Okay. And in Solaris 2, so mainly swap space is used for backup. This is again not in Solaris 2, Solaris 1. So mainly swap space is used for backing up of anonymous memory. It means in the main memory, apart from operating system and our program, there will be a space allocated for these data structures, stack, heap and uninitialized data. So these things will be used as a backing store for pages. Okay, so swap space only used as a backing store for pages of anonymous memories like stack, heap and uninitialized data. So under Solaris 2, allocate swap space only when there is a need to page out. So when we have virtual memory, we won't store the pages in the virtual memory. Only when there is a need, when the main memory is full, only in that situation swap space is used in Solaris 2. And under Linux, so how swap space is managed is, so this is nothing but the swap partition or the swap space, a swap file, and again it is divided into page slot. These things are nothing but page slots of some size 4 KB, and each page is associated with swap map. So here 1, 0, 3, some integer count is given. So what it says, 1 means this page is referred by one process. 0 means this page slot is free, so that it will occupy some pages from the pages which is paged out can occupy this space. And here 3 for this page slot indicate this page is referred by 3 shared process. Okay, so that's it about the swap space management. Thank you.